In this video, I'll be solving part 2 of Wassce 2025 Physics Paper 2. We'll be solving the remaining 5 questions. I've already solved the first 7 questions in part 1. So if you haven't watched the first video, please check my YouTube channel. Thank you. Let's dive into business. Now, you need to find a sheet of paper to write these questions down, because we will be solving these questions and we need to solve it together. So please find a sheet of paper, write the questions down, so when you're solving the questions, you will know how I come out with some values. For a part of number 8 questions, we were asked to sketch a diagram showing all the forces acting on the craft along the plane. Now, we were told that this particular craft, it will push up the incline. So when a force is applied on the body will accelerate. And the acceleration will always go with respect to the applied force. So it means that the applied force will go in the direction of the acceleration. So the pull force is going upward. Now, we know that the frictional force always acts in opposite direction to the applied force. So since the pull force is going upward, the frictional force will go in opposite direction of the applied force. And this particular plane is what is inclined at angle of theta. So resolving all of these forces there, because the weight here having 2 components, it has the horizontal component, vertical components. So since the last year, it means that this side will be cos and the other side will be sin. So we have mg cos theta, here we have mg sin theta. The normal reaction always acts in perpendicular direction to what? To that of the surface. So the surface here is the inclined plane. So you observe that the normal reaction, it points what? It points upward. But this normal reaction and this weight acting in opposite direction. So the 2 forces are equal in magnitude or opposite in direction. So we are safe to say R is equal to mg cos of theta. Now let's resolve all of the forces. So the first thing is that we know that the frictional force and that of the weight acting in a horizontal direction will act in the same direction. So we have the frictional force here, which is mu times the normal reaction, and we have the weight mg sin of theta. Both of the forces act in the same direction, so we add it, resolve it. And the pull force will act in opposite direction to that of the frictional force. So we have minus sign attached here, but we send it across the change to what? Positive. Now, we know that R is equal to mg cos of theta. Don't forget about that. So we place the value of R. We have the pull force is equal to mu, coefficient of friction, times mg cos theta plus mg sin theta. We can see the influx of mg. So we can factor mg as our common factor. So factor mg, we have the pull force to be equal to mg mu cos theta plus sin theta. So mg comes out the parenthesis. Now, let us collect our data. So in the question, we're given the coefficient of friction to be 0.620, and we're also given the mass to be 50 grain, but we need to convert this value from grain to kilogram. So we have 0.05 kg, and we're given the constant value of acceleration of gravity to be 10 meter times second square inverse. The value of theta there, which is the angle of inclination, to be 30 degrees. We'll be substituting all of these values into our equation. So substituting the values there, we come out to this. Now, place all of these values on your calculator and solve it, and you come out to the answer to be 0.518 Newton. This is our pull force. So the next part of number 8 question, we were asked to calculate the work done in pushing the craft up the clamping, but we were told to express our answer in kilojoules. So we all know that work is equal to force times distance. The force here represents the pull force, the force that push the craft up the clamping. So we have already calculated the pull force to be 0.518 Newton. So replacing this value, and we know that for the plane there, the clamping there, the craft or cover the distance of 2 meters. So S is 2 meters. So replacing the value, we have work equal to 0.518 Newton times 2 meters. So multiplying this, we have work to be equal to 1.036 joules. But we were asked to express our answer in kilojoules. So converting the value, we have 0.00104 kilojoules. So this was the expected answer for question number 8A on Wassce 2025 or physics paper 2. Now, let's move to question 8B. Let's see. So question 8B, I will ask to list 3 methods that we use in reducing frictions. So these are the 3 methods. The first method we have lubrications. Lubrications mean either oiling or greasing. We have polishing, and we have using rollers or ball bearings. So these are 3 methods that we use in reducing friction. So question 8B, to add, we were asked to explain the term coefficient of kinetic friction. So this is our expected answer. So coefficient of kinetic friction simply means the ratio of the frictional force to the normal reaction between two surfaces in relative motion. So this is the answer to question 8B2R. We'll talk about coefficient of kinetic friction. Is that the ratio of the frictional force to the normal reaction between two surfaces in relative motion? In fact, the frictional force depends on the coefficient of friction and that of the normal reaction. So the frictional force F is just equal to mu, the coefficient of friction, times the normal reaction error. All right. So let's move to the next question. Question 8B3R asks us to define viscosity. So this is the expected answer. Viscosity is the internal resistance of a fluid to flow. Let us move to question number 9. So this is question number 9. Take a sheet of paper, write the questions down because we'll be solving all of the questions and we're answering the questions. All right, so let's move. Let's dive into business. So let's look at questions 9AR. We're asked to explain the difference between temperature of 80 Kelvin and that of changing temperature of 80 Kelvin. So temperature of 80 Kelvin just means an absolute temperature of 80 Kelvin. While changing temperature of 80 Kelvin means different temperature of 80 Kelvin. So the temperature of 80 Kelvin just means absolute temperature, and changing temperature means difference in temperature. So this was the expected answer. Let's move to the next part, 9A2R. So 9A2R were asked to solve. So we were given the upper fixed point of the thermometer to be 15.0 centimeter, and the lower fixed point was 0 centimeter. And we were asked to calculate the temperature in degrees Celsius. So we'll be using a centigrade or scale of the thermometer. So the centigrade scale for the boiling point of water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. So take that into consideration. So we have the upper fixed point minus the lower fixed point of the thermometer, and the mini course minus the freezing point, equal to the upper fixed point, which is the freezing point. I mean, the upper fixed point is steam point minus the freezing point or the lower fixed point, all divided by the mini course minus the lower or freezing point. So 15.0 minus 0 will get us in 15. So 15 times 15.0 times T, we get 15T. 100 degrees Celsius minus 0, we get 100. 100 times 5.0, we get 500. So we would have T to be equal to 500 divided by 15 because we want for T to stand by itself. So dividing 500 by 15, we have 33.3 degrees Celsius. So this is our answer for question 9A to R. So now move to question 9A 3R. We're asked to state one relationship between coefficient of linear expansion and coefficient of area expansion. So that was it. The relationship between alpha. So alpha here represents the coefficient of linear expansion, or we can say coefficient of linear expansivity, and beta represents the coefficient of area expansivity. So the relationship between the two is just like beta there is just equal to twice the coefficient of linear expansivity. So this is the expected answer. All right. Now question ER. The question reads, pressure of a gas thermometer is 600 millimeter mercury at S point. So you were asked to write the questions down because I'll be solving the questions so you can follow the step of me. So now at the S point given to us, we have 600 millimeter, and at the steam point or the boiling point, we have 1050 millimeter mercury. So for this, we are still solving on the centigrade scale. So we have our upper fixed point minus our lower fixed point. So you'll see we have the upper fixed point there, or the steam point, to be 1050 minus the freezing point to be 600, and we have that of the mini course scale to be 900 minus the lower fixed point to be 600, equal to, we are solving the centigrade scale, so we use the boiling point and the freezing point. So the boiling point represents the steam point. The boiling point is 100 degrees Celsius minus the lower fixed point of the thermometer, which is 0, and the main cause is T, which is unknown, the temperature. So minus the freezing point, which is what? Which is 0. So doing this, we have 100 times 300 divided by 450. So here, when we subtract 900 from 600, we get 300. We cross multiply to have 100 times 300. So when we subtract 1050 minus 600, we have in 450. 450 times T, we get 450T. Dividing both sides by 450 because we want T to stand by itself. So multiplying 100 by 300, we have 30,000. So 30,000 divided by 450, we have 66.7 degrees Celsius. So this is the final answer to this question. So let us move to 9B2R. For 9B2R, we're asked to explain the relationship between temperature and that of pressure of gases. So the relationship between temperature and pressure can be explained through pressure's law. So we say pressure is directly proportional to absolute temperature at a constant volume. So a constant volume. So this is the expected answer. So this is the relationship between temperature and that of pressure. All right. So let us move to question B3R. Question B3R will ask to name and state the law that best describes the relationship between pressure and temperature of the gas. So this is the expected answer. So the relationship between the pressure and temperature of the gas is best described by Gay-Lussac law, or also known as the pressure law. And this law states that for a fixed amount of gas held at constant volume, the pressure of the gas is directly proportional to its absolute temperature. So this is the expected answer. So let us move to question number 10. So for question number 10, this question refers on refraction of lenses. An object is placed 16.0 centimeters beyond the principal focus of a converging lens. If an image is found at a distance of 12.0 cm beyond the other focus, calculate that 1 RC focal length of the lens and 2 RC magnification of the image form. So the first thing we need has to sketch our diagram. So let's sketch our diagram to solve the problem here. Now, remember that this 16.0 centimeter is the distance from that of what? Is a distance from the focus, from the first focus, from the object to that of the first focus length. And this 12.0 centimeter represents the distance of the image to the second focal length. So that will dive into business. So the first thing that will draw our lens is our lens. Let us draw our principal axis. Yes, the principal axis to pass through the lens. And next thing that will indicate the object, yes, the position of the object. And let us also indicate our focus length. Yes, the focal length. So now, on the other side, we have the image, and on the other side, we also have the second one, the second focus length there. The distance between the object and that of the focus length given to us in the question to be 16.0 centimeter per quadrant, or we place it by x. And the distance between the image and that of the focus length, that will say is y, even though we know it to be 12.0. So now, know that the distance from f to that of the lens is nothing but the focal length. So that is f. And the distance from f on the other side to the lens, again, the same as f. So the distance from the object to the lens is the object distance, and that is u. But u will be equal to x plus the focal length f. So we are safe to say that the object distance u is equal to x plus the focal length f. On the other side, the distance of the image to the lens is the image distance, that is v. But the distance from the image to the focal length is y, and the distance from the focus length to that of the principal focus there is f. So we are safe to say the image distance will be v is equal to y plus f. Remember this. So we can now determine the focal length by using Newton's length formula. But let us set out this first. So x was given to us as 16.0 centimeters. So x is the distance from the object to that of the focal length, which is what? I mean, the principal focal, which is what? Which is x. So it's 16.0 cm. And y was given to us as 12.0 centimeters. So y is the distance from the image to that of the focus length, which is what? Which is f. So it's 12.0 cm. So Newton's length formula to find our focal length, and from there we will find our magnifications. So that is question 10A to R. So let us solve 10AR first. So using Newton's length formula. So Newton's length formula tells us that x squared is equal to x times what? Times y. So x value here is 16.0 centimeter and y value here is 12.0 centimeter. So replacing that value, we have x squared to be equal to 16.0 times 12.0. So multiplying 16.0 by 12.0, we have 192. So we have f squared to be equal to 192. We will be taking the square root on both sides because we want to find f, not f squared. So eliminating the square, we have f to be equal to 13.9 centimeter. So this is our focal length. Now, we can find the magnification. We know that the magnification is equal to the image distance v divided by the object distance u. But the image distance v now is represented by y plus f, and the object distance represented by x plus f. So replacing the values there, we have magnification is equal to y plus f divided by x plus f. So now we have our value of y to be equal to 12.0, and we have our value of x to be equal to 16.0. And we also have our value of f, which is the focal length, to be 13.9. So replacing all of the values, we have 12.0 plus 13.9 divided by 16.0 plus 13.9. So adding the value and dividing our final answer, we will come out to 12.0 plus 13.9, we have 25.9. When we add 16.0 plus 13.9, we have 29.9. Dividing the two values, we have our magnification to be 0.866, but we want to round it to one decimal place, so we have 0.9. So this is our final answer. Let us move to question 10 or B. Question 10B. So question 10B reads, a ray of light experiences a minimum deviation when passing symmetrically to an equilateral triangular prism. Calculate the angle of incidence of the ray when the refractive index of the glass is 1.5. So let us firstly set our data. So since this triangle is equilateral, it means that the angle of the prism there is 60 degrees, because equilateral triangle, it has all its angle equals 60, 60, 60. So the angle of the prism A is equal to 60 degrees because the triangle there is equilateral. So the next thing we have our refractive index given to us to be 1.5 as a refractive index. And we also have or asked to determine the angle of incidence. So that's I equal to question mark. But let us firstly find the angle of refraction. Now, in an equilateral triangular prism, we have the angle of refraction to be equal to the angle of the prism A divided by 2. So we have R to be equal to A divided by 2. But we already know that A is equal to 60 degrees. So replacing A at 60 degrees and dividing by 2, we have R to be equal to 30 degrees. So this represents our angle of refraction. Now, using Snell's law to find the angle of incidence, we have Snell's law, or mu is equal to sin R divided by sin R. So mu represents the refractive index. So we know that R is equal to 30 degrees. So replacing R at 30 degrees and mu is equal to 1.5. So replacing the value, we have 1.5 equal to sin R divided by sin 30 degrees. Sin 30 is 0.5. So multiplying 0.5 by 1.5, we have sin R to be equal to 1.5 times 0.5. So doing this, we have 0.75. We want to solve for R, so we take the inverse of this trigonometric function. So we have R to be equal to sine inverse of 0.75. So taking the inverse, we have our final answer to be 48.6 degrees to be our angle of incidence. All right, so let us move to question 10C and D. So for question 10C, we'll ask to draw a diagram illustrating regular and diffuse reflection respectively. Regular reflection usually occurs on a smooth surface, like for example, the reflection on the plane mirror is an example of regular reflections. And diffuse reflection or irregular reflection occur on a rough surface. So this is the diagram. So for this reflection, which is regular, it occurred on a smooth surface like the plane mirror. And this surface is polished. And for diffuse, it occurred on a very rough surface like the wall. So this is diffuse. These are the incidence rate and these are the reflected rates. So this is the diagram showing the difference between regular reflection to that of diffuse reflection. So let us move to see. We're asked to mention two uses of resonance tube. So I name or three, I give three uses so you can take any two of your choice. So resonance tube is used to determine the speed of sound in air. It is also used to find the resonant length with a known 10 Fox frequency. So I gave three, you can take any two of your choice. So now move to the next question. So that is question number 11. For question number 11, please take a sheet of paper and write the question down because we'll be solving it again. So at least you can follow this tutorial. It's helpful for you. So let us dive into business. Now, for question number 11 is you would ask for first of all the circuit diagram. So in this circuit is or arrow C circuit. The arrow stands for the resistance and the C stands for the capacitor. So this particular circuit is usually drawn on alternating or current. So this is a symbol for resistor and this is a symbol for capacitor. So this is a circuit that you are asked to actually draw. So the next thing we were asked to calculate the capacitive reactance of the circuit. So that move. So we're given the capacitance to be equal to 0.5 microfarad. So micro means 10 to the minus 6 power. So we replace micro by 10 to the minus 6 power. And we're also given the resistance to be equal to 30 ohms. The capacitance there to be, the frequency there to be equal to 8.0 times 10 to the 3rd power hertz. So this is the frequency given to us. So the refractive index is represented, the capacitance reactance is represented by XC. So C represents the capacitance and X represents the reactance. So capacitive reactance are all resistance or resistors. So XC is equal to question mark. So we can see that Z is the impedance. We're also asked to determine the impedance. Impedance is equal to question mark. So let us calculate XC first before calculating Z. So we know that the phase angle is also equal to question mark. The phase angle is represented by phase, or we can say phi, is equal to question mark. So finding XC, we know that the capacitive reactance XC is just equal to 1 divided by, we can say omega times C, or we can say omega, which is equal to 2 pi F. So it's 2 pi F times C. So there's a formula we can use to calculate the capacitive reactance. Don't forget about this formula. It is on alternating current. All right. So replacing the value of the frequency and also replacing the value of the capacitance. So we have XC to be equal to 1 or divided by 2 pi times, it is the value of the frequency, 8.0 times 10 to the 3rd power times this is the value of the capacitance. So we have 0.5 times 10. We know that macro means 10 to the minus 6 power, so then 10 to the y to the 6 power. So solving these values, we have our capacitance reactance to be equal to 39.8 ohms. It is also our resistance, right? Reason why it's in ohms. Now, the next part of the question, I saw to determine or to calculate the impedance. So the impedance is just equal to, or Z is equal to the root of the square of the resistor or the resistance plus the square of the capacitance reactance. So we have the resistance given to us to be equal to 30, and we have the capacitance reactance that have all been calculated to be 39.8. So replacing the value there, we have the impedance to be equal to the square of 30 plus the square of 39.8. So solving this value and taking the root, we have the impedance to be equal to 49.8 ohms. So this is our answer. Now, the last part of this question, we're asked to calculate or determine a phase angle. So the phase angle phase of phi is just equal to XC, which is the capacitive reactance divided by the resistance R. So XC have already been determined to be 39.8, and we have the resistance given to us in the question to be 30. So replacing these values, we have 39.8 divided by 30. So when we do that, we'll have 1.326. So taking the inverse of the value, we have our phase angle to be 53 degrees. So this is the answer. Let us move to question 11b. So for question 11B, we were asked to name 3 main components in an AC circuit. So for the AC circuit, we have the capacitor, we have the inductor, and we also have the resistor or the resistors. So these are the 3 main components of the AC circuit. So let us answer this. So the resistor is represented by R rod, inductor L, capital L, and capacitor C. So these are the symbols for these components. So there is a symbols for resistor, the symbol for inductor, and the symbol for capacitor. So resistor or resistance is measured in ohms. There is a symbol, and inductor is measured in inductance is measured in Henry. This H, and capacitance is measured in farad and represented by F. So this is the answer to question 11B. So let us move to our next question, that is question 11C. So for question 11C, we were asked to solve a problem on converting galvanometer to that of voltmeter. So let us see. So in the questions, we were given the volt to be equal to 300.0 volt. I said you should write the questions down. And there's the volt given to us. And we were also given the deflections of current equal to 75 milliampere. Milli means 10 to the minus 3 power. So dividing this by 1,000 for the sake of simplicity, we have 0.075 ampere. So we have converted from milliampere to that or ampere. So this value, it represents the full scale deflection current. So RG is the resistance of the galvanometer is equal to 50 ohms. And we were asked to calculate the value of RS. So RS represents the total, we can say the hard resistance here, because in order for us to convert galvanometer to that of the voltmeter, we have to firstly connect it in series, and we have to use very hard resistance. So we are asked to determine Rx in this particular question. So replacing all of the values here, we have V to be equal to 300. We have RG, which is the scale deflection current, to be equal to 0.075 ampere. We have our RG, and which is the resistance of the galvanometer, to be equal to 50. The reason we added RG plus RS because we were told that it will be arranged or connected in series. So for series resistors, we calculate it by taking the algebraic sum of the individual resistors. So we say RG plus RS. So replacing this value, we have our voltage to be 300, current to be 0.075, and the galvanometer resistance to be 50. So multiplying 0.075 by 50 and sending it across. So we have 0.075 by 50, we have 3.75, and 0.075 times RS, we have 0.075 RS. So sending 3.75 across, the sign will change from positive to negative. So we have 300 minus 3.75. So doing this, we have 296.25 equal to 0.075 RS. We want for RS to stand by itself. So we divide both sides of the equation by 0.075. So doing this, we have our final answer to be equal to 3950 ohms. This is our final answer. All right, so let's move to our next questions. 12A. For 12A, 1R and 2R, for A, we were asked to state two factors that determine susceptibility of an atomic nucleus. So I gave you three, so you can take any two of your choice. So the size of the nucleus also determines the stability of the atomic nucleus, binding energy per nucleons, and that of neutron to proton ratio. So you can take any two of your choice. And we're also asked to mention three differences between nucleus reaction and that of chemical reaction. So these are the three differences between that of nuclear reaction to that of chemical reactions. So for nuclear reaction, it involves nucleus. And chemical reactions involves electrons. So in nuclear reaction, large energy change occur, while in chemical reaction, a small chemical or energy change occur. So in nuclear reaction, usually new elements can be formed, or chemical reaction, no new elements also can be formed. All right. So let us move to the next question. So that is question 12B. Now the question reads, this question is on nuclear physics. So let me bring this on the side to see the question correctly. All right. The half-life of the radioactive substance is 30 days. So this, the half-life given to water is capital T. What time is small t is required for 3/4 of its original mass to disintegrate? So the first thing you know that if 3/4 of the original mass disintegrates or have been disintegrated, it means that 1/4, or we can say 1/4 of the mass will remain. So let's see how we get this. All right, solution. So when 3/4 of the substance have disintegrated, 1/4 of the original mass remains, which means that we will be subtracting or 1 from that of 3/4 to know or to know the remaining mass that will remain. So the one that disintegrated already will take it to be about 3/4. So the one that remains will say 1 minus 3/4. So we say n or n naught to be equal to 1 minus 3/4, because 3/4 represents 3/4, which will be equal to 1/4. So 1/4 of this particular mass will remain, is a remaining mass. So this is a mass that disintegrated. So we use the remaining mass to solve these particular questions. So writing our formula down, we have n over n naught divided by 1/2, all raised to the time taken, or divided by the half-life. So we were given the half-life to be equal to 30. So we place in the value, and we have n over n naught to be equal to 1/4. So placing the value now, we have 1/4 equal to 1/2, or raised to the t over 30. We need to make the two bases the same. So we can raise 1/2 to the second power to get the same 1/4. So 1/4 can also be written as 1/2 all squared, because 1 times 1 is 1, and 2 times 2 is 4. So we can now see that the two bases are exactly the same. So 1/2 can cancel out 1/2. So what will remain will be 2 equal to t divided by 30. So we can write it down as 2 is equal to t divided by 30. We can now do our cross multiplication. T times 1 is t, and 2 times 30. So we have t is equal to 2 times 30 days. So multiplying 2 by 30, we have 60 days. So this is the answer to Wassce 2025 question number 12B. So now move to our next question. So for question B, finish, we move to question 12C. So question 12C, the question reads, the wave function of a photon is 1.33 times 10 to the minus 16 power, or EV. Calculate the frequency of the photon whose energy required to inject surface electron is 1.9 times 10 to the minus 16 power EV. So EV means electron volt. So the first thing we have to convert all of the value from electron volt to joules. We have already given the conversion factor here given to us as 1 electron volt equal to 1.6 times 10 to the minus 19 power joules. So it means that we would term each of the value by 1.6 times 10 to the minus 19 power to express our answer from our EV electron volt to joules. So let us dive into business. So we converted the work function here given to us as 1.33 times 10 to the minus 16 power EV times the value by 1.6 times 10 to the minus 19 power joules. We have 2.128 times 10 to the minus 25 power joules because EV will cancel EV here, so we level joules. So doing that for the energy, also we have 1.9 times 10 to the minus 16 power EV electron volt equal to 3.04 times 10 to the minus 35 power joules. We obtain the value by multiplying this value 1.9 times 10 to the minus 16 power by the constant value given to us 1.6 times 10 to the minus 19 power joules to obtain this value here. So now the Planck constant was given to us as 6.60 times 10 to the minus 34 power joules times second. This is a Planck constant, we'll use it. So let us write our equation down to solve. So we're asked to calculate the frequency F. So we know that from photoelectric effects, we know that E, energy is equal to the Planck constant times F, the frequency, minus the work function. So replacing these values, we have E already given to us, we have H, and we want to find F. F is unknown, we have the work functions. So replacing the value, we have, firstly, to make life easier, we actually make F the subject. We can leave it and replace the value. You will still obtain the same answers. So making F the subject, we send the work function across a change from negative to Y to positive. So we have F to be equal to E plus what? W divided by Y divided by H. So we send this across the equal sign. A change to Y positive, we divide both sides by F, divided both sides by F. So we have E plus the work function divided by H. So replacing all of the values down, replacing the energy E plus replacing the work function and dividing by the Planck constant. So we will firstly add this and this. Our value we obtain, or the sum obtained here, will be divided by the Planck constant. So doing that, we have our final answer to be 3.224 times 10 to the 8th power hertz. So this is our final answer for question number 12C. Now, question 12D was asked to differentiate between binding energy and mass defects. We know that binding energy is just the minimum energy required to disintegrate to split the neutrons in the nucleus of an atom. So a mass defect is just the difference in masses between, or the sum of the masses of the neutrons to that of the mass of the nucleus. So this is the expected answers. So mass defect is the difference between the sum of the individual nucleon masses and the mass of the nucleus, while binding energy is the minimum energy required to separate a nucleus, complete it into its nucleons. So thanks for the time. See you in my next video. Please subscribe to my YouTube channel.